Hey 8th grade, this is Miss Harkness, and this video is for Eureka Module 3, Lesson 1, where we are looking at what lies behind same shape. In this lesson, I'm just going to review how we know two shapes are similar, and then I'm going to review how to find the scale factor, as well as use the scale factor to find a missing measurement. Let's start with these two squares, for example. We have the one on the left and then the one on the right. Which of these shapes is the original figure? We would say that the one on the left is the original figure because it does not have prime notation. So this one on the right is the image. It is the figure that is created after the dilation. So since we know that the one on the left is the original and the one on the right is the image, we can now answer some questions about these shapes. A very common question you'll find in dilation questions is, what is the scale factor? There's a really easy way to remember how to find this ratio. So what was the rate that they were using to reduce or enlarge the figure? And I like to use this saying no, where N is my new shape and O is the old shape. New being this one right here, the old one being this one. So as you can see, my larger, let's call this shape 1 and shape 2. Shape 1 is larger, shape 2 is smaller. This is a reduction. But in order to find the scale factor, we need to know how did they go from 12 to 6. Now you're probably saying they divided by 2, they divided by 2. Yes, that's exactly what they did. They divided by 2. But with scale factor, we're usually multiplying. So let's take a look. I like to use this equation where old times the scale factor equals the new. So we know that 12 is the old, we know that 6 is the new. Now, in order to find the scale factor, this whole no concept I'm going off of says new to old. So new to old. 6 divided by 12 is 1/2. The scale factor is 1/2. Let's look at a couple more examples. Here in this diagram, ABC is similar to DEF. So A becomes D, B and E, and then C becomes F. So the order and how we name this similarity does matter. Okay, so let's take a look at this question. This is my old, this is my new. Let's pick a corresponding side. I'm going to go with EF and BC, new over old. Well, my scale factor is 2. It really is that easy. You just have to know how to set up this ratio. Once you know how to create that fraction, it's really as simple as simplifying. So this simplified down to a 2. But what if this on the left, what if this was my original? Then I'm going to have 10 over 20, which would be 1/2. These are scale factors that are reciprocal to each other. All right, so let's move on. What about this problem, for example? We know that the original is 4, but then we can see this enlargement has an x, and we know that our scale factor is 3. Well, I know that old times the scale factor equals the new. So let's just plug in the values that I know. I know the old one. I'll put that there. I know the scale factor. Put it there. 4 times 3 is 12. So when you know the scale factor, it actually feels easier than having to find the scale factor because it's just a multiplication problem. I hope this video helps you see how to do this type of math. As always, this is Miss Harkness.